Alrighty, let's get started on the next lesson in our statistics unit. This do now says, according to the following box and whisker diagram, which of the data sets below, which of the following values represents the lower quartile of this range? That would be Q1, which would be this right here. And let's see what we're going by here. 10, 12, 14, 16, 18, 20. Yep. So in between 10 and 20 would have to be one of these, and it is answer choice 16. Alrighty, so what are we going to do today? Today we are going to calculate standard deviation to understand the variation within a set of data. What do I mean by this? The measures of central tendency, which are the mean, median, mode, min, max, can describe the center of a set of data, but it doesn't tell everything about the data. Two sets of data can have the same mean, but look radically different depending on how varied the numbers are. So, let's look at this. In the past, most banks required that customers wait in separate lines at each teller's windows, but most have no change to single waiting lines. The following table represents waiting times in minutes of two banks. We have this bank who has a single waiting line, and this one who has multiple waiting lines. So, for each bank, find the mean waiting time. Alright, so for the first one and the second one. Alright, so if we have 4, 7, and 7, divide that by 3, the mean of this bank would be 6. And the other one, 1, 3, and 14, and then divide it by 3, also has a mean of this. So what do I notice? I notice mean are same, but Mulberry Bank has a bigger range. At the first bank, you're waiting like 4 or 7 minutes. That's not that different. But at the second bank, Mulberry Bank, you could be waiting 1 minute or 14 minutes. That's a drastic difference. So what is different about the data from each bank? Oh, well, I just said that, is that the second one has a lot bigger range. And what do you think, why do you think that most banks have changed to a single waiting line? I think so people can expect to wait around the same amount. So people wait around the same. Because I'm going to be annoyed if I'm waiting a lot longer than somebody in another line is waiting. Alright. Now, standard deviation is a measure of variation that is usually used the most when a set of data is symmetrical. Therefore, two forms of standard deviation, sample and population, are used. The standard deviation of a set of data tells us the typical deviation from the mean. How much different is this from the middle number? So, population. The population is used when the data being analyzed includes the entire set of possible data. So if you're analyzing all the people in the U.S., you would use population. But if we're only using a few people from the U.S., then we would use the sample. So let's look at this. A car dealership has 100 SUVs on its lot. A collection of 6 SUVs were examined and their fuel efficiency in miles per options are shown below. How do you know if this is a sample or a population? Alright, well it says the car dealership has 100 SUVs and only 6 of them were used. This would be sample because only 6 out of 100 used. Find the sample standard deviation of the data rounded to the nearest hundredth. Alright, so I know you don't see my calculator here, but let me just show you something real quick. If we remember from yesterday's lesson, we reviewed all the different stuff that you can get when you type this in the calculator. You can get all these different symbols. This SX means sample standard deviation, and this OX looking thing means population standard deviation. And we can use the same steps where we type this in the calculator and we click stat calc, and then we get these data. So let's look at this. Alright, so I'm going to type these into my listen spreadsheets: 21, 21, 21, 30, 28, 24. Alright, then I'm going to click menu, stat calc, and then one variable statistics. I'll click OK. I'll click OK. And when I am looking for what is the sample standard deviation, I look for that SX button, and it says rounded to the nearest 100, which would be 3.97. Alright, let's look at this next one. Jenna bought a new hybrid car. Each week for a period of 7 weeks, she noticed that the fuel efficiency in miles per gallon of her car. The results are shown. Since this is the fuel mileage for every week of the 7 weeks, it is population. Alright, so 44, 45, 44, 43, 44, 45, 44, 43. Alright, now I'm on my calculator. Menu, stat calc, one variable statistics. I click OK. And then I am looking for this looking button for population, and that would be 0.75. 76 actually, because I have to round up. Alright, and what does the result from part A indicate? So what does this result indicate? That the data is pretty close to the mean. We're not that varied. We're pretty close to the mean. Alright, let's look at this one. The following data represents the pulse rates from a sample of students at a college. Right there we know it's going to be sample deviation because they only use a sample of people at college. Find the mean and standard deviation of each of these. Alright, so I'm going to type in the first one. 58, 60, 62, 62, 64, 66, 66, 66, 68, 68, 70, 70, 72, 72, 74, 76, 84, 90, and 92. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, yep, 19, I do have 19. Okay, so for men, let's put in our mean. Alright, so I'm going to click menu, stat calc, one variable statistics, click OK, and then I'm going to click OK. And what is my mean here? I'm looking for the word mean. Alright, so mean gets this little X with a bar on top, so that would be 70.5. And now my standard deviation would be, since I'm using the population one, the sample one, 9.4. Alright, now let's see for women. Alright, let's type in the data for women. 62, 62, 68, 78, 78, 80, 82, 88, 96, 96, 100. Alright, menu, stat calc, one variable statistics. I'm going to click OK, click OK. Alright, my mean here would be 80.9, and my sample standard deviation would be 13.3. Alright, do the pulse rates of men and women differ? Well, yeah, because the mean for women is a lot higher. Who has the higher pulse rate? It would be the women. And how do I know? From the mean. Is the amount of variation in pulse rates similar among men and women? Who has more variation? The women, because we start, some have 62 because ranges from 62 to 100, whereas men range from 58 to 92. It's a smaller range. Because the women range would be that much, but the men's range is that much. Alright, and let's look at this last one. Which set has the smallest standard deviation? Justify your answer. Alright, so I am going to go find data set 1. There is 122, there is 2 23s, there is 124, there is 4 25s, 126, and 127. Alright, I'm going to click menu. I'm going to click statistics, stat calc, one variable statistics. Alright, and my standard deviation for this one would be, the sample one would be 1.5, because I don't know that this is everything. Now for this one, I would get 20, 22, there's 2 23s, there's 2 25s, there's a 27, 28, a 29, and a 30. Alright, menu, stat calc, one variable statistics. I'll click OK. Okay. And my sample standard deviation would be 3.6. No, 3.3, sorry. Alright, and let's look at this last one. I have a 21, 22, 23, 24, 24, 25, 26, 26, 28, 28. Alright, menu, statistics, stat calc, one variable statistics. Click OK, and I would get 2.4. So which one has the smallest would be set 1, and we could say because 1.5 is less than the other numbers, and the largest would be set 2. And that makes sense because set 2 is the most spread out of all of them. And that is all. That wraps up our lesson on standard deviation.